Hello students, welcome back. In the previous class, we have started a chapter that is chapter number 5, Upthrust in Fluids, Archimedes Principle and Flotation. And we have studied few topics such as buoyancy and upthrust and characteristic properties of upthrust. So today we will study about reason for upthrust. So what is there inside the liquid which causes upthrust or upward force to an object immersed in a liquid. So now we have read that a liquid contained in a vessel exerts pressure at all points in all directions. So if there is I'll first of all draw a vessel. So if there is a liquid in a vessel, then this liquid exerts pressure at every point. Okay? It exerts pressure at every point. Now the formula for that pressure in the previous chapter we have studied was H rho G. Okay? This was the formula for the pressure. And what we have also studied is, as we go on into the liquid, into deep down the liquid, as we increase the depth, the pressure increases. The pressure over here is less than the pressure at the bottom. So more we go down, more will be the pressure. So keeping that in mind, we will further understand the reason for upthrust. Now, the pressure at a point in the liquid is same in all directions. So if you consider a point over here, the pressure in all directions is equal. Okay, but pressure over here compared to this pressure is different. But at this point itself, the pressure exerted in every direction is the same. So at one point the pressure is same, but if you consider another place, another height, okay, because pressure depends upon the height or the depth, the pressure is different. So that you have to keep in mind. Now when a body, say a block of area of cross section A. So suppose we have a body immersed inside a liquid. We have a body immersed inside a liquid. The area of this body, okay, this area is A. So A is the area of that object which is immersed inside the liquid. Now the pressure, now what we can see over here is there is two surfaces. Okay, suppose this is a block, this has got four surfaces. This surface at this one and this another surface at the bottom, they have got the same area. Now the pressure over here due to liquid will be from downward. So pressure at this point will be because of the liquid which is acting upward. So let us consider this as P2. The pressure over here is due to liquid which is there at the upper surface. Pressure over here be P1. Now as I have told you, the pressure of the liquid or the upthrust of the liquid is different at different points. So at this level, this is at height H1. Okay, this height is H1 from the surface. We always measure the height of the liquid from the surface. Now this height is H2. Okay? This height of the surface is H2, this height is H1. Now we can clearly see that H2 is greater than H1. So because H2 is greater than H1, your pressure P2 is automatically greater than pressure P1. So pressure over here is more than the pressure at that top surface of the object. Now let us consider the pressure at the side of this object. If you have got the two sides at the same level, okay, they have the same height, both the sides have the same height, so the pressure at this part and pressure at this part will get cancelled out. So only P1 and P2 pressure has to be considered, and what is that? P2 is greater than P1. Now another formula of pressure is force per area. Okay, formula for pressure is, force is pressure multiplied by force per area. So from here what we can see is force is directly proportional to pressure. Now what it means by directly proportional to pressure, More the pressure, more the force. Simply understand that wherever the pressure is more, force also will be more. So, and what is force over here? Force is upthrust. Name of the force exerted due to liquid is upthrust. So, force at this part, that is F2, is greater than force over here. This is F1. Okay. I hope this till here it is clear. Now, if F2 is greater than F1, what happens? If the downward force is greater than the upward force, what happens? The object will be pushed upward. Ultimately, the greater force will win. Okay, not the lesser force. So, if F2 is greater, if this force is greater than the upward force, then the object will be pushed up. That is the reason of upthrust. Okay, upward force due to a liquid. This is the reason, because pressure is more. Force will automatically be more, and due to the greater force, the object will be pushed upward, not downward. This is the reason. Now, because this area, like there is a huge block, so the depth is different. Due to the reason of the depth, pressure will be different. Suppose in the same situation, we consider a thin sheet of paper. Suppose a very thin sheet, which doesn't have got this amount of volume. So if you consider a thin sheet and immerse in the water, what happens? The pressure at top surface and the bottom surface of the object will be same. So the object will sink inside the liquid. The object will only float if there is a difference of height. Okay, difference of this height of the object. If there is no difference in the height, the object will sink. Another thing, this we have considered for a square object or a symmetrical object. This can be true for any sort of object which has got a height. Suppose, for example, cylinder, human body, a bottle, anything which doesn't have a definite shape. Even that object will experience the upthrust because of the volume of that object. So this is the reason for an upthrust. Now another topic is, we'll continue with that. Upthrust is equal to the weight of the displaced liquid. Okay, I'll just write down the topic. Now the topic is upthrust is equal to the weight of the displaced liquid. I hope this you have experienced. Whenever you put a heavy object in a bucket of water, in any container of containing water, then what happens? The level of the liquid will rise. As soon as you put the object, the level of the liquid will increase. That is what we do by looking at the water level itself. But over here, we need to understand how this happens. Okay, how this happens, and that is the specific topic. That is, upthrust is equal to the force. Upward force is equal to the weight of the displaced liquid. Displaced liquid means if you put an object, the water will rise. The amount of the rising level of the water is actually known as the displaced liquid. So now in a book, the definition is given as, when a body is immersed in a liquid, upthrust on it due to liquid is equal to the weight of the liquid displaced by the submerged part of the body. So more the object is inside the water, more the upthrust. So that upward force is equal to the amount of liquid which is being displaced. So you understand it better when we prove that. Okay. First of all, we'll draw a diagram which is given in a book also. Okay. Here is a liquid. Inside the liquid, a cylindrical body is placed. Okay. Inside the liquid, cylindrical body is placed. So we are considering a cylindrical body PQRS. Okay. Cylindrical body PQRS is kept inside the is kept inside the liquid. Now the height for this bottom surface will be h2. The height for this top surface will be h1, because we know that there will be a difference of pressure at the surface. Now the pressure over here at the top surface will be downward, which is P1, and pressure in this bottom surface will be P2. Similarly, force over here will be F2, force over here will be F1. Now, let the upper surface PQ of body be at depth H1. This upper surface is at depth H1. This lower surface is at depth H2. While its lower surface RS be at depth H2 below the free surface of the liquid. Whenever we measure a height, I have told you several times, we measure from the top free surface, okay, top surface. So at depth H1, pressure on the upper surface PQ. So pressure on the surface PQ. The formula of pressure is H rho G. So over your upper surface is H1 rho G. Okay. Now downward thrust on upper surface PQ. Downward thrust means the force on the upper surface. Okay. Force or the thrust is equals to pressure into area. This is the formula, and if you remember, it is pressure multiplied by area. So pressure over here is H1 rho G. If we consider area over here at the top surface, area at the bottom surface is the same. We will consider this as A. So let us write this as equation number 1. Now, similarly at the height, so pressure at this surface RS, okay, at this surface RS will be H2 rho G. Similarly, height is H2, rho is the density of the liquid, G is the acceleration due to gravity. Now, similarly, force or the upthrust at this surface will be pressure into area. Now, pressure is this, H2 rho G multiplied by area. This will be equation number 2. Okay. The horizontal thrust at various points on the vertical side of the body gets balanced because liquid pressure is same at all the points at the same depth. Now it is said that at this horizontal line, okay, this point, this side, at this side, the pressure at each and every point, this side and this side is equal, so both the pressures get cancelled out. So we are only considering the pressure at upward and the lower surface. Now we know that from here what we know is over here the pressure at the height H2 is more than the pressure at height H1. So automatically F2 is greater than F1. So whenever we try to find the difference of force, what we do is we subtract. So the total force FB after subtracting, okay, the total force FB after subtracting will be F2 minus F1. Greater force minus smaller force. Okay. This force over this point will be greater, so this minus the lower force. Now, what I will do is subtract these two equations. F2 is this, it is H2 rho G minus area is there, over here is H1 rho G A. Now, everything is same except for H2 and H1. So, this will be rho G A inside the bracket H2 minus H1. Okay. Now, what is this A H2 minus H1? A is this part A is area, H2 minus H1 is the height, okay, this height. If you subtract H2 minus H1, we will get this height of the cylinder. So, area into the height gives the volume. If you know the formula of volume, volume is area into height, length into breadth into height, or in case of a cylinder, it is area into height. So this part gives us the volume. So from here, force becomes, in place of this we are writing volume rho G. Okay. Now upthrust FB is equals to V rho G. Now from here, volume into density. What is the formula? Volume into density gives the mass. Okay, this gives the volume into density is mass. If you know the formula, density is equals to mass divided by volume. If you take it over here, density into volume is equals to mass. So density into volume gives mass. Mass into acceleration due to gravity. Now again, mass into acceleration due to gravity gives us the weight. Okay, this gives us the weight. Which weight we are talking about? We are talking about the weight of the liquid which is being displaced. Okay, you can write it down. Fp, that is upthrust, is equals to weight of the liquid displaced by the submerged part of the body. So from here, it is proof that the amount of liquid which is being displaced when we put an object, the same amount of force will be exerted by the liquid. That is what this whole thing proves. Now, there are a few things to note. First one is, if a body is completely immersed in a liquid, the volume of liquid displaced will be equal to its own volume and the upthrust then will be maximum. Okay? So, when we immerse a full body, suppose for example, if you immerse your body inside a swimming pool, so some amount of volume of the water will rise. So the amount of water which is rising is equal to the volume of your own body. Okay, that is the first thing. And the force also will be equal to the volume of the water which is being raised. Second one is, although the above result is derived for a cylindrical body, okay, this is only for a cylindrical body, but it is equally true for the body of any shape and size. This thing is equally true for any body, any shaped body, irregular, regular, any type of shaped body, that will be true. This thing will be true. Okay, I hope this is clear till here. I will stop it over here itself. We will continue in the next class with another topic, that is Archimedes principle. Okay, Archimedes principle is one of a very important topic, and that we are going to discuss in the next class. Now, factors affecting the upthrust. This we have already done in the previous topic, that is, what are the characteristics and condition of body floating. All this thing I have discussed about the factors which affects the upthrust, okay, upward force. So that 2 points are given in the book. You can go through that by yourselves. Okay, so in the next class, we will discuss about Archimedes principle. This much for today. Thank you.